So good evening everyone. So we'll wait for 5 more minutes. After that we'll start. So everyone can access that YouTube video, right? Like one or two persons told like I couldn't access this. Can everyone please confirm that? Praveen, did you check that? Yeah. Okay. Okay guys, we'll start the session. Is my screen visible? And I'm audible, right?
Yes,
Okay, thank you. So until last class, what we have done is we have almost ready to set up a COGEMS model, like doing smooth profiling and setting up the boundary conditions. So what are the pending tasks is how to set up tanks and ponds, pumps and control sets. So today's class what we are going to learn is to do these things only. So first we will be doing like how to set up the tank and set the pond outlet structure to the free outfall. The second thing is how to control the flow in that pipe which is exactly downstream to that pond. So there are multiple ways of reducing the pipe flow in that. So one is like directly we can reduce it in the flow. Another thing is like we can make a orifice in the pump, sorry, orifice in the pipe. And the next thing is we can place a vortex or orifice in the pond outlet structure. So first thing is we directly going to discharge the water from the pond to the outlet. The second thing is we are going to reduce the flow in the pipe by using orifice in the pipe. And the second thing is we can reduce the flow directly in the pipe by using a vortex or orifice in the pond outlet element. The third part is we are going to use the we are going to use the control sets, like after some period of time the pond need to discharge the water, like kind of thing. So that thing we can be done by using the control sets and the orifice in the pump, say in the pipe. The last part is how to set up the pump and how to control the pump using the elevation and the time. So these are the four things we're going to see detailedly in this session. First, we'll go to the model. So this is what I have created. Just for understanding, I will show the profile. In this you can see, like first I have discharged the outfall into the in the pond, then the then it is discharged to the wet well, then we have placed one pump here. After that it will be discharged to the manhole and directly to the outfall. So this is what we're going to do in the detail. First we'll create a child model here. It is ECS2. Then go to alternatives, create one child here. So after changing the alternatives, it won't disturb the parent model. So first what we're going to do is we're going to inactivate the elements which is available here. First create a selection set for this. Make it CS1. So here the selection set is created. So now we're going to inactivate this selection set. Go to active topology, edit active topology mode, select from the drawing. Here this tab will be opening. In that, go to this folder, select the selection set which we created now, then select. So this will be unselected. So go to active topology, display inactive topology. This will disappear the selected items. Now one more thing we need to do is boundary condition. Put one more boundary condition here. CS2. Change the boundary condition. Go to scenarios, search for boundary condition, change it to ACS2. Now check the boundary condition, go to boundary condition, make it as free outfall. Free outfall. Now validate it. No errors coming. Just run it. So the model is run. Go to flex table, catchments, search for volume, runoff volume total runoff. Okay, right click it, go to statistics. You can get the total runoff volume which is generated from the catchment, which is 180 meter cube. So just assume some depth for 180 meter cube. I am assuming 3 meter depth. So the area required is 60. So for the 60 area meter square, 3 meter depth, we are going to create a pond here. Pond and tank both are same in the sewer gems. So go to layout, pond, just draw the pond. If you click the pond, the scaled area has been generated, like 763, which is huge. We can adjust it here also, but it is quite hard to keep the same area which we created now. So this is not considerable, so leave it as it is. So go to click the pond, go to physical, select the volume type to elevation area, click this. So consider the elevation. This is the elevation area table. So here the cover level is 36, the invert level is 33.24. So which means cover level is 36, invert level is 33.24. So manual will be here. So the invert level will be 33.24. We're going to make a tank like this, so which is little bit higher than the invert level. So we are going to consider 1 meter above from the invert level. So 33.24 means 34.24. 34.24 minus 3 is 30.24 will be the invert of the tank. So we need an area of 60 meter to occur our volume 34.24. So whatever the area which we mentioning here, this will be considered as a pond area. So this area is like a scaled area, so we can, this is for our visualization only. There is no use of this. We can reduce the size like here also, but whatever the area which is mentioning in the table will be considered as a pond area. Almost I'm keeping like this. So after creating a pond, we need to discharge the outfall into the pond. For that, go to discharge, outfall element, go to boundary condition. In that boundary condition type, select the boundary element. Okay, in that boundary element will be appears. Here we need to select this pond 5. Actually previously it was selected to this pond. See, this pond is already selected here, pond 4. So for this, just a little bit move this, make it disappear. Over here, boundary condition type is boundary element, select the boundary element, click it. So whatever the water coming from this outfall will be traveling into this pond. Okay. Then open the profile so that better understanding can be done. Select any manual little bit here, select the pond element, open this. So what I told is we have created a little bit above from the invert, so the pond is starting from here like 30.24, 30 point, what we created, the starting invert is 30.24, the ending invert is 34.24. So that is the 30.24 is starting, the ending is 34.24 here a little bit. So now we are going to run and check the efficiency of the pond here, because why I am telling to check the efficiency of the pond is because here some amount of water will be not stored here, like a little bit of here it won't be stored here, it will be stored in this conduit itself. So after running this we can check the efficiency. So whenever we are creating a pond, maximum try to store some water in the inline storage, because that will reduce the excavation cost of the pond. If you click this, go to result, go for percentage fill maximum. Here see 72.8 percentage only filled. So we have some more options like we can reduce the pond size. So to make the efficiency of the pond, I am going to reduce a little bit. Instead of I'm reducing 1 meter here, 31.24. So here I'm going to only keep 2 meter, then run it. So maximum try to keep 90 to 95, maximum try to keep it 90 itself, um, because in site condition we need to give some freeboard also. Check the efficiency result percentage filled here. See, 81.8%, 8% is only filled. Okay, leave it as it is. So go to this profile. See, this is the maximum HGL which we are getting. So we have some more space to accommodate some more water here. So for our class, this is more than enough for this. So like this we can reduce and make the efficiency of the pond. Okay. So after this, after storing in pond, we need to discharge it outside. So how to make outflow for this pond? For that, go to layout, select this pond outfall element here. Pond outfall element, keep it here. Select the pond outfall element, go to the ground elevation, which is the tank elevation, maybe 36. This won't affect much. Then select under this pond outlet is there, upstream pond. Select the upstream pond, go to this, select the upstream pond, select it. After this, make a conduit here. And so in CY Gems, one more is option is like if you have mistakenly done manual here, no need to delete and draw it again. We can make outfall here. Click the outfall and click it above the manual. So the manual will be changed to outfall. Okay. So here the invert level is 31.24. I'm keeping the outfall a little bit down towards that. So make the invert level of the outfall. Go to invert level. Select the outfall first. Go to the ground elevation, which make it 36 itself. And invert level will be 31.2. So based on the pipe size, we need to create that invert stop invert. So first we will fix the pipe size here. So whenever we are creating a new conduit, there will be no physical will be arranged for that. First we need to arrange the physical. So go to the conduit type, select the catalog. So the last pipe is about 800. So I'm going to fix same 800 here. 800 is not available. So I'm fixing 700 now. Fix it. Check the start invert and stop invert. So which is connected to the pond outlet structure and the outfall. Start invert is 0. So connect it to the bottom of the pond, which is 31.24. So after that, stop invert will be false and make it as 31.22. So here the slope is generated 500. So for the 700 we can maximum 500 is okay only, but try to keep whatever the diameter we're using the same pipe, same slope. So little bit okay. 3 is 1000. Okay, this is enough for this. So what are the invert which we are keeping here? We need to fix it in the outfall invert. Go to this, paste it in the outfall. Now the depth is about 4.77. Just see the profile now. So this profile is up to this, so I'm going to add this part also. For that, click the profile, right click, edit, select from the drawing, select the outfall. Okay, you can see this. So our pipe is connected a little bit here in the lowest part of the pond, then it connected to the outfall. The outfall cover level is a 36 and the bottom level is 31.23. So you can see, if you see the details of the profile, right click, show profile annotation. So we can see the profile also, like slope, diameter, length, invert, start, stop, everything will be available here. Okay, so we have created like this. So we're going to run this. So before that, see, there will be no graph in this, no outfall. Here we can see the graph, like maximum of 18.81. So here we can see the graph. So if you want to know the detailed value of highest point, we can go to the data, right click, sort to descending. So the maximum value is 18.81, which until stored which is the value until stored in the pond. So now what we have done is we have make a pond outlet here and making a free discharge of this. So now run it. Some invert of the link, some warning is came. Invert of the link adjacent to the stop mode is below the, actually what we set is same invert all only, but here model what exactly want is we want to make it as stop invert as true. See, the value is 31.23. If you make it as true, 31.23 will be there, but this warning it won't come. After running, it won't come. That is some small bug in COGEMS. Now we can see the profile. So now the water from the system first discharge into the pump, into the pond. After that, it discharged free outfall. So this is what is happening here. So now what we're going to do next is so I'm getting some control of they're telling like until 24 hours no discharge, after 24 hours please discharge the water. Until 24 hours I need to store it in the tank itself. For that what we're going to do is we're going to make a orifice in the pipe. Okay, first we'll do like this, after that we move on to step by step. So orifice is a kind of structure, like it is a control structures. There are multiple control structures available in this area. So if you go to the conduit, if you go to here conduit control structure, orifice, weir, and this one I don't use. These are two control structures I use to control the water. First I will go with the orifice. So before that I need to tell like something I missed. To reduce the flow, yeah. So after reducing the flow, we'll go to that. So how to reduce the flow after coming out from the pond? There are multiple ways. So first I will do like if you click the conduit, go to this. This is like some random. This is like just to check the model whether it can restrict the flow and what are the backflows are happening. So we can restrict the flow. First we'll check the flow here. Go to the graph. So the maximum flow is 18.16. So I'm restricting to 15 lps here. So click the conduit, go under physical, you can find that flow maximum user defined. So I'm fixing 15 lps here. Okay, just run it. model run. So right click, graph, we can see until 15 lps we have restricted the flow. So that's what is happening after restricting the flow. Previously it was like 18 point something, and this some equal amount of flow transfer won't be happening there. So now it was like this. So how to how to define this, how to define this in the model, like without putting a random value. First remove this, make it as 0. So now what we are going to do is we are going to install one orifice here, orifice in the pipe. Okay, so first before that check the model, run once. See the graph. So it was like 18, after that a sharp drop. I want to note everyone this one, this value 18.16, make a note of it. Then we're going to place a orifice in the pipe. So for this first we'll check 700 is the pipe. Orifice is the kind of structure where pipe size will be reduced. So it is like if your pipe is like 700 means if you install one orifice here, so it will reduce the pipe size, like whatever the pipe size you are making, like we can reduce to 400, 315. That kind of structure is the orifice will do. It will reduce the pipe size and make the flow. So go to components, stormwater control, conduit control structure, uh, go to this orifice, rename to orifice. So this is the crust elevation. What is the crust elevation? Crust elevation is nothing but the invert level of the conduit. So the invert level of the conduit is 31.23, which means this value is the crust elevation. So where we want to place the orifice, like here or here or fully to the bottom. So what we're going to do is like this we're going to place the orifice. So invert level of this is 31.23. Okay, 31.23. So then the flap gate, the purpose of the flap gate is to not to get the negative flow, like if our structure is connecting to something existing manual, existing structure, some amount of flow may come like this. So our flow may go our flow may stay here for some time. So in that case some reverse flow will be happening. So to avoid this condition, the flap gate should be in on. Then the structure type is orifice, coefficient leave it as it is. Orifice type bottom outlet. So this is time to open and close. When to open and close we need to mention, like if you are mentioning like 600 minutes, it will be open after 12 hours. Now for now we will be placing it as 0, because we're going to place we just going to reduce the pipe size, whatever the we simply going to reduce the pipe size. So this is the pond. So here 700 pipe is there. So what we're going to do is simply we're going to reduce the pipe size to 400. Then after that what we're going to do is until after 12 hours, until 12 hours it will be 400, after that it will be 700. These two conditions we're going to try now. Okay, first make the diameter to 400 mm. Make sure the units are in make sure the units are correct. Make it as mm, make it as hours, and other than that make it as meter. Okay, so previously it was 18.16. Now we'll run the model. Now the flow has been little bit reduced, I feel. Same only. No. After fixing the components, we need to fix that control structure in the pipe we didn't fix. That's why it's showing the same thing. So click the pipe, go to as start control structure, as stop control structure, which means we are making a control structure in the start or stop. So I'm going to make it in the stop, make it as true. Select the control conduit control set which we created for this. Make it in the starting itself. We are placing orifice here. Okay, now run it. Right click, graph, still it's same. Now it's reduced. See, so from 18.61 it reduced to 17.51. So now what we're going to do is, in the starting there will be more flow, so I need to reduce that flow. After that, getting a more flow is enough. It's okay for me. So the condition what we're going to do is, it's 700. So make it this as 12 hours. So until 12 hours it will be 400 to get that less flow. After that, uh, after that it will be 700 next 12 hours. So this is what we're going to make. After before that I need to check whether this flow is happening until 12 hours or not. See the graph. So actual flow is happening after 12 hours only. What we can do is, so until 13.72. Okay, until 13 hours we'll make it as 400. After that it will be 700. Okay, so let's see how to do this. Go to components. So we almost set the control structure for the orifice. After that, go to extension, SWMM extension, control sets, create one control set, like make it as orifice 1. Okay, so for the orifice what we're going to do is, there are the for every component, there is different way of writing this code. This is like a code language generated for COGMs. So if you see this, this is for pump. So for the pump, what we need to do is, if simulation time equal to your time, then the we need to mention the pump, then the pump name, then status. For the pump we need to use the status, then on or off. Okay, for the orifice we need to use setting, and for the close it should be off 0, for the on it should be 1. Okay, so the same thing we are going to do is, we are going to do in our model. So I'm telling like, after 13th hour, until 13th hour it should be off. Okay, until 13th hour, if simulation time is until 13th hour, it should be, the orifice should be in off. So then orifice, put the orifice name here. So we'll check the orifice name. Orifice name, conduit control structure 1 they are given. I will make it as orifice 1. Okay, the same name should be in that area, in that place, otherwise it won't run. Orifice. So until 13th hour it should be off. So after 13th hour it should be on. So this is the priority one, this is the priority two. So like same way you need to enter the code for controlling the structure. Okay, so after this, first we need to set the conduit control structure. Then we need to place that conduit control structure in the conduit which we're going to make. After that we need to make swm extension which we can control by time. So after this, after doing all these things, go to home, options, click this. So here if you can see one apply swm control set now. So here we need to choose which control set we need to use, like true. Make the control set which we make now, or if is fun, this is the control set which we're going to run for now. So here we need to choose this, otherwise it won't take. Okay, now after setting everything, run. Some error. So we made something error in the control set, that's why this error will come. This error doesn't shows what error is this, we need to find what is it. So maybe the error is due to the control set only. Orifice 1, the name is too large, instead of that we make it as O1. If simulation time is less than 13, then the orifice O1 setting should be off. Is greater than or equal to 13, the orifice setting should be on. So now it's running. So try to make the orifice name as much as small so that no errors will come. So what we done is until 13 hours it should be in off, after 13 hours it should on. So we can see this until 13 the orifice was fully closed. So what happened here is we didn't fix the time for the orifice. If you go to conduit, we didn't fix the time for the conduit. Okay, so here what happened is orifice acts like a uh, orifice acts like a gate. Until 13 hours it was closed. Okay, until 13 it was closed. We can see this 13, it was near to 13 to now. Until 13 it was closed, after that it was open. Suddenly more amount of flow has came from here. So we can check the flow here, it will be quite higher, 173. So for that after 13th hour more amount of flow came at the small instant, so that's why the flow is huge here. So here what we're going to make is go to the control set, make 13. If you place any number here after 13 it will be open. uh, so I'm making after 13 pipe should be 400. Go to the conduit, right click, graph. Previously it was 175. It was reduced to 173 because we reduced the pipe size. So this is how we can use this orifice here. So one more kind of orifice we can use it directly in the pond outlet structure itself. Click this, remove the control sets, options, go to this, remove this also. So now the model is free from the orifice. This is our normal outflow graph, which is highest of 18.16. Now what we're going to do is we're going to make orifice in the pond outlet structure itself. So the water will be coming out from the pond outlet structure will come through that orifice only. Okay, go to that component, stormwater control, composite outlet structure. Okay, here open new composite outlet structure, make a orifice. So here these are the inputs which we given to the orifice. First type is orifice, then the direction flow which we need only forward flow only. Then the openings will be 1, the coefficient will be 1, the elevation will be like bottom elevation of the tank. Make it as orifice. So the tank bottom elevation is 31.24. Go to that 31.24. So after that we need to fix this one will be the name, make it as orifice one itself. So this will be nothing, tail water only. So when to open, when to close, like this is like level based control structure. So when to open, when to close. So uh, what are the values which you are giving in that period, it will be open, after that it will be closed, like so while entering the value also we need to ensure that elevation on value should be lesser than the elevation off value. So this should be lesser than this value. So maximum elevation we need to keep here. So if you see the elevation like 31 to 34, so until 34 I'm going to open, like it will be starting from 32. Go to composite outlet structure, orifice, until 34 it should be open, it should start from 32. So we make the dia of 315 here. So previous dia is 700, in that we are getting 18.16. Now we are making a dia of 315. That too it will open when the elevation touches, the tank touches the level of 32. Okay. So after this, go to pond outlet structure, select as control structure, then orifice 1. This is fixed here. So to this profile, if you see this, until it touches the 32, the orifice will open, then the water will flow down and it will go in the 315 diameter. So after it reaches the 34, it will be offed. So there will be it won't reaches 34, I feel it will reach until here only. So this is the condition which we are given. So we'll run it and see the result. Previously the result, the graph is 18.16. Now we're going to run this. after running, go to conduit. Okay. It was reduced because the discharge is happening through the 315 pipe. So this is how we can control the flow by using orifice in the pond or structure. So any doubt in this? After this, one more method is there. Like instead of orifice, we can make a vortex. So after running, this graph will be generated. So we don't need to generate this and all. This will be generated automatically. Vortex flow. So first create a composite outlet structure. In that, create a vortex flow. Make this name as VV. So this vortex valve is kind of spinning structure. Like first we'll see the orifice. So this is what will happen. So orifice will kind of one small gate. So maximum flow will be reduced to the pipe size which we are making over there. So in that pipe the discharge will be happening. Vortex valve. No, I'm not getting the exact image. I will explain here. So it's a kind of some spinning object will be there. So in that, after getting the water, the spinning object will restrict the flow and we'll be getting the less flow from that. So this will be happening when we're using the vortex. So go to vortex, same elevation will be 31.24, which is the bottom elevation of the pond. Here we are going to make only the forward flow. Then the vortex wall tail water condition same only. Here we need to fix the vortex wall and edit like how much flow we need to make when the water reaches that edge. Okay, here our water, here our water will be reaching like bottom to the top, which is 31.24 to 34.24. So in that we need to make a graph like how much flow we need to happen when it reaches that particular level. Okay, so for that we need to make that vortex flow. Go to this vortex, edit. So this vortex will be coming. So here I'm going to make like from 34 it need to be 10, the 32.5 same 10, make it as 12, otherwise in 33 it should be 15. Okay, this is the graph which we are making. So likewise, otherwise we can, so this is the graph which we are making. So like when it reaches the 32, the flow will be like in the 15. So when it reaches the 32.5 it will be like 12. When it reaches the 10 it will be like 10. 32, 33 it will be like the flow coming from the vortex wall will be like 10 liter per second. We done this. Make the vortex flow here. So this is also the same condition. The elevation of should be higher value, the elevation out should be the lower value. The what are the values which you are making in this between two, this will be act as a vortex wall. So I'm making the same thing like it is a 34, it need to be start in the 34 and ends in the 32. It needs to start in the 32 and stop in the 34 when it is the elevation. Okay, So nothing we have created. So after running, the rating table will be created automatically. After this, so we forgot to fix it here. Please mind that without any control structures it was like 18.61. Without any control structure. So after control structure it was reduced to, after using the orifice it was reduced to 15.02. Now we are going to make a vortex valve. Go here. What are the things which we are creating in this stormwater control? We need to change it accordingly. Go to vortex. Not we are creating here. So we have almost already fixed composite outlet structure vortex valve. So now we'll run this. The most cases we'll be using only the orifice. The rare case only we'll be using this vortex. For the knowledge purpose, I'm sharing how to use this vortex and all. So after this, click it here, right click graph. See, because of the vortex flow it was like this. So maximum it was reaching like 1.04. So it's so what we fixed is we can see in the profile. So when it reaches 32, the flow will be like 15 lps. So the flow 15 lps will be coming. After it reaches 32.33, it was like 12 lps. When it reaches 34, it won't reach 34. There will be no flow from that value. When you see the graph, so the value which we are given is not that much exact. That's why the graph is not matching with our value. We need to go to components. Vortex valve. Edit this. So from remove this. Getting 5 lps. 5. So it is almost reaching near to that 0.4. Some issues are happening with that value. I will tell you in the next class clearly about this value, but we can use this to reduce the flow which is coming out through this pipe. Previously it was like 18.61 orifice. By using the orifice it is like 15.02. By using the vortex it was reduced to 0.4. Graph. maximum values 0.37. So these are the different types of methods we can reduce the flow in this pipe. Other than that, the next is we have done this, vortex, this also done, this also we have done. By using the orifice we can control. Then the final part is about how to set the pump and how to control the pump using the elevation and the time. First, whenever you are going with the pump, it's better to go with the wet well or manual, which we need one inspection chamber for that pump. So for that purpose only we are going with the wet well here. Click it, change to wet well, set range to elevation. First we'll check with the bottom is 31.24, the top is 34.24. Go to the wet well, base is 31.24. I need to start 31.25 initial. This is the starting stage of starting water surface elevation in the tank. So this also will be keeping it as the maximum is 34.24. So we almost fixed the wet well. No need to fix it for 34, because if you fix it for 34 it will be coming until the tank itself. So we will be fixing until the cover level. So 36 is the maximum. So inside this only the pump is going to be there. So but in model we can't, we're not able to make it inside. We're going to make it outside of the wet well only. So for that we'll be installing the pump here. Click the pump which is available in the layout, pump, click the pressure pipe. So whenever you are using the pump, we need to use the pressure pipe upstream and downstream. So click the wet well and create the pump until pump. Then so junction will be created. So the last class someone asked like where to use this pressure junction and all. The pressure junction is mainly used in the mainly used when multiple pressure pipes are coming. We need to use that pressure junction. After that, downstream of the pump we can use this pressure junction. Okay, then make this pressure pipe. We're going to make one manual here. After that one outfall. So this will be in gravity. So from the bottom of the tank it will be pumped to this manual. After that it will be traveling to gravity to the outfall. So this is the condition which we're going to try now, which we're going to do now. So we have set the properties for the wet well. So this is the overall properties which we need to set. So when you come under this, there is one pump pond area option will be there. Like if the wet well is fully filled, so there will be some amount of water will be stagnant above the wet well. So in that area we can in that place we can mention the pond area. Now as of now no need of this. So this is all the requirements for the wet well. So another thing, we need to tell the elevation ground which is 38, same as it is the outfall. Then go to the pump. So fix the ground level same as outfall. Fix the invert which is little bit down towards the wet well, so there will be some flow will be there. Here what we fixed is for the wet well we fixed off base of the pond little bit down, make it as 31.22. Click the pond, Set inward to stop 31.22. Okay, 31.21. Let's just little slope is more than enough. Then we need to define the pump definition, like how much liter per second it need to travel, how much lps is needed to travel this to evacuate this volume. Okay, for that we need to fix this first. Ground level is 36.5, inward level is 35, so make it as 1.5. From that, gravity, ground level is 37, inward level is 35, make it as 2 meter. If you go to home, profile, something, junction element. For the junction also we need to give the elevation. Thirty-six. Make the junction elevation exactly to the right angle of like where we need to cut. So I need an elevation until here, like approximately 35.2. One second. Little bit down. 35.1 will be better. Okay. This is for just for model purpose only. We don't give any output like pressure junction and this kind of things and all. So what we fixed is just see the annotation. We have a small slope of 5 to 1 here and 4 to 1 here. This will be minus only because this is against the gravity. So from here the slope is 51, here it is 0, so we need to fix this also. Little bit down. Setting what to stop is true. Okay, 35, 34.8. making 178. Okay, then after that fix the pipe sizes. From the last we will be going, go to this conduit, make it as 700. So that is the starting pipe size. So whenever we are designing, the pipe size should be in uh, incremental, like lower to upper, so it should not be like upper to lower. Okay, so here we are fixing to 700, so we are going with the 700. So we can go to 800, 900 or something but I don't have catalog right now, so I'll be going with the 700 itself. So it is fixed. Then so another thing is after making the pump, we are making a pressure pipe. So for that it should be in virtual. In the physical, virtual option need to be in true. Go to the material, HDPE pipe, make it as 150. Same thing for the all pipes, make it as true. HDPE pipe. So we almost fixed. Just we'll see the profile first. Everything is okay. First remove the things which we have ordered already. go to explicit solver, it should be in false. Okay, false. Click this. We are not making anything right now. After this it should be in false itself. So then we need to make the pump definition. So pump definition, go to this, click the pump, go to the physical pump definition, edit pump definition. So this is the pump which I have already made, like 5 lps with the head of 2 meter. So the uh, head should be like from here to this invert, wherever we are connecting. Okay, so the invert is like 31.2. Here the manual invert is 35. I'm connecting little bit above, like 700. So this is a simple calculation for the head. What I'm making is from 35 minus 31.2. This is the difference between this point and this point. So I'm going to connect it here, this little bit above, so which is 700 mm dia. So I'm just adding 0.7, so making 4.5 as the head for us. So go to the components, pump definition, true, flow should be like 12 lps 12 lps until 4.5. So 0 to 4.5 it will be traveling at the 12 lps speed only. Okay, efficiency 0, this and all, everything is fixed. So after that click the, go to pump definition, go to pump definition 1. This is what we make now, make it named as pump 2. Okay, so now we will run this. So the output graph will be generated in the 12 lps. Some error came. No item is selected for. So for the pump we need to select the downstream element. So here if you go to this, click the pump, go to downstream link. So it will show this, these are two things. So downstream element is P9. We'll select the P9. This line is P9 only. Then what are the errors? Pump definition is wrong. Pump upstream link should be connected to the wet well. P11. Okay, sorry. After pump, this pipe is P11 only. I thought I made a mistake. After pump it is P11. So we need to connect it to P11. Then another, elevation on value is less than the bottom elevation on the control node junction. So what we're going to do is we are not going to set anything as of now. So we'll be fixing it as true. So it won't take the elevation value on or off, which and all needed. So whatever the water will come, it will be pumped and discharge it to the manhole. So if you make it as false, we need to fix the value, at what elevation it need to be pumped. If you are not making anything, make it as true and just run the model. This is how we need to fix the pump in the model. Okay, everyone understand until this, right? So we'll see the graph of this. See, until 12 it was pumped and it is discharged to the outfall. So this is how we need to fix the pump. Okay, so no need to start from the initial itself. Okay, from the initial stage it should be off. So after some time it need to be on. So elevation on need to be like 32, it should be on. I'm making it as 31.5 because our tank lies in 31.24 to 34.24. Then it should be off 32.5. Okay, making it as false. So the, what will happen here, is the pump will on when the elevation reaches the 31.5, and it will off on the elevation when it reaches to 33.5. Okay, if you run this, okay, error. SWM engine failed during the calculation. Initial status need to be on. Some mistake. Failed during the calculation. See the report. It should be off until this. When it reaches 33, pump should on. So the error is due to the elevation off value should be lower, the elevation on value should be higher. So whenever the storm, if you open this, close this, close this. So whenever the wet well is reaching up to 33, the pump will be on. Okay, that's why the result will also show until 30. After reaching the 33, the pump should on and it will pump the water to this area. If it is below 31.5, the pump is will be off. So this is what we can control the pump by using the levels. Now we are going to see how to use to control the pump using the time. Okay, close this. Make it as true. Make it as 0, not to cause any error in the future. Initial status on. So the pump name is PMP4. Okay, go to components, SWM control sets. So make a control set for pump. For the pump, what we need to use is pump name and status should be on and off. So this is the rule for that. So rule number 1, the if simulation time is greater than 15, then pump PMP4, our pump name is PMP4, should be off. Until 15 it should be off. So after 15 it should be on. So that is the 2 priority which we are giving now. So the model ran. We'll see the last pipe so that we can get to know. So until 15 it should be okay. We didn't set it in the options. Go to this, apply SWM control set, select this, go to pump, which is set at now, then run it. So if you don't set that control set which we are making in this components, you won't be getting the same results. So go to drag this and see the time, which is 15. So after 15 it pumped and discharge is happening. So this is how we need to fix the pump orifice and the control sets. So then next option is wear. We almost done this. This is also done. direct flow reduction pipe orifice. Okay. Okay, time is also up. We'll close with this. In the next class we'll be learning how to use the vias. So that will be the final class of the COGEMs. So after that I will be setting up like from starting to ending how to set the model, how to create the scenarios and all. One small session will be there in the next class. So after that we'll be moving to the ICM. So any doubts from this until now? Can we close the session? Are any Chelsea, Vishal and I, any doubts? No, no. I hope you will be understanding every steps which I am doing. If I am going a little bit fast, just tell me. I will be go slow and show the details of the structures and things which are happening. Okay, guys, we'll see you in the next class. Bye.